This is Cambridge IGCSE for Chemistry Paper 4, Theory, Extended, for February-March 2025. Question number 1, using numbers only, state the percentage of oxygen in clean dry air. That will be 21%. B, typical operating temperature in degrees Celsius used in Haber process. That would be 450 degrees Celsius. Number 3, number of atoms in a diatomic molecule. Diatomic means 2 atoms. Next, maximum number of electrons in the second electron shell of an atom. For the second shell, it can occupy a maximum of 8 electrons. E, number of hydrogen atoms in an alkane with 7 carbon atoms. Given that it's an alkane, it will follow the general formula of CnH2n plus 2. Since it has 7 carbon atoms, it will mean that there will be a total of 2 times 7 plus 2 hydrogen atoms, which is equivalent to 16 hydrogen atoms. F, number of particles in 1 mole in standard form. That will be 6.02 times 10 to the power 23. Question number 2. This question is about ionic compounds. State what is meant by the term ionic bond. The term bond means electrostatic attraction, and ionic bond is actually a strong form of electrostatic attraction. And the word ionic means that this bond is found between oppositely charged ions, such as in the following example, potassium sulfide, where potassium ions are strongly bonded to sulfide ions via this electrostatic attraction. Now, moving on, potassium sulfide K2S is an ionic compound. Complete the dot and cross diagram in figure 2.1 of the ions in potassium sulfide. Show the charges on the ions. Now, potassium from the periodic table, for its atom, it has an electron arrangement of 281, given its position in group 1 and period 4. For sulfur atom, it has an electron arrangement of 286, given its position at period 3 and then group 6. Now, this will cause them to try to achieve a 4 outer shell by, for potassium, it will be donating 1 electron to form potassium ion, which is K+. You will have an electron arrangement of 288. And then for sulfur, they will gain 2 electrons to form sulfide ion, and that has an electron arrangement of 288 as well. To show this, we have to draw a circle for potassium, showing the remaining electrons in the third shell by using dots. And this applies for the second potassium ion as well. And both of them carry a positive 1 charge. Then for sulfur, it gains 2 more electrons, and the 2 more electrons actually come from potassium. All right, each of the 2 potassium atoms. So I draw 6 crosses for its original electrons, and then 2 dots to show it came from the potassium atoms. And this will carry a 2- charge. Moving on, C. Ionic compounds form giant ionic lattices. Figure 2.2 shows part of the giant ionic lattice structure for sodium chloride. Compare diagram in figure 2.2 to show the ions present. Use plus for sodium ions and minus for chloride ions. 1 chloride ion has been completed for you. So in that case, it's gonna form ionic bonds with the potassium and negative ions, right? Sorry, let me rephrase that. They will form bonds between oppositely charged ions. So you just need to make sure that it's alternating, since they react in a 1:1 ratio. So alternating positive and negative arrangement. Next, state the name given to any positive ion. That will be a sodium ion. Sorry, no. It's not an example, right? The name given to positive ion is a cation. Now, moving on, D. Ionic compounds can be decomposed by the passage of electric current using inert electrodes. State the name of this process. That's just electrolysis. And 2. Write the ionic half equation for the reaction which takes place at the anode when molten potassium bromide is decomposed by the passage of an electric current. Now, given that if we are doing molten ionic compound, it will mean that the ions will get discharged without any forms of competition. So at the anode is a site where it is positively charged. It will attract anions coming from the electrolyte, and in that case, it's our bromide ion. This bromide ion will undergo oxidation at the anode, which means donation of electrons, and form actually a bromine molecule. To balance this equation, since there are two bromine on the right-hand side, I put a 2 in front of Br minus and a 2 electron to show that 2 negatives, like how it turns into a neutral particle. Now, question 3. Name the products and state the observations at the negative and positive electrodes when dilute aqueous potassium bromide is decomposed by the passage of an electric current. Now, given that it's a dilute aqueous solution, it means that apart from potassium and bromide ions in the electrolyte, there is also hydrogen and hydroxide ions in the electrolyte. Now, given that, we will know that the product at the negative electrode, which is also known as the cathode, right? We will actually collect hydrogen as it's located at the bottom of the, what they call a reactivity series compared to potassium. It has a lower reactivity compared to potassium, so it's preferentially discharged at the cathode. Now, for that, since hydrogen gas is formed, we will see bubbles at the negative electrode, or you can see colorless bubbles. You may also say it's fizzing or bubbling, sorry, or effervescence. Now, looking at the positive electrode, instead, since it's a dilute solution, the priority is given to our hydroxide ion here. So when hydroxide ion is discharged, it turns into oxygen gas and also water, as well as electrons at the anode. Now, this equation can be balanced by a 4 hydroxide turned into a 2 water and 1 oxygen molecule. Now, since these are the products, so let's write that down. Oxygen as the product and also water as the product. Now, the observations at the positive electrode will be similarly colorless bubbles as oxygen gas is formed. Moving on, the halogens are the group of elements in the periodic table. Chlorine is a member of this group. Take the group number of halogens, that will be group 7, and state how many halogens there are in the group. Look at the periodic table, there are 6 of them. Suggest the identity of the halogen which has the highest density, which is the one at the bottom. As going down the group, density increases, and that will be Tennessee. Whereas the halogen is most reactive in the group, right, will be fluorine. Since fluorine is the most reactive, all right, the idea is going down the group, reactivity decreases. Now, D, state the name of the negative ions formed by halogens. So halogens tend to gain electrons to achieve a full outer shell to form halide ions like chloride, bromide, iodide. Next, state how many occupied electron shells there are in the bromine atom. The number of electron shells can actually be figured out by looking at the period of the period table. Now, bromine atom is located at the 4th period, so it has 4 electron shells that are occupied with electrons. F, state the noble gas which has the same electronic configuration as a bromide ion. So that will be krypton. As bromine gain electrons, it has 1 extra electron, which shifts to the next element that will be krypton. Krypton has the same number of electrons as a bromide ion. Moving on, aqueous chlorine reacts with aqueous potassium iodide. One of the products formed is iodine. Complete and balance the ionic equation for the reaction between chlorine and iodide ions. State symbols are not required. Now, chlorine is more reactive than iodide. It will displace it out of the solution. And in that process, chlorine is reduced to form chloride ions, and iodide is forced to oxidize to form iodine. To balance this equation, we simply just have to put 2 chloride as there are 2 chlorine atoms, and 2 iodide as there are 2 iodine ions. Sorry, 2 iodine atoms in the molecule. Next, explain why this reaction is defined as a redox reaction. Give your answer in terms of electron transfer. Now, we see clearly that electron, right, our chlorine, or should I say iodide? Right, let me rephrase that. Iodide actually has donated electron, right, electron, which means it undergoes oxidation by itself. And in that process, donate electron to our chlorine molecule here. This causes chlorine to be reduced, right? Basically, it gains electrons to form chloride ions. Right? If you want to know the half equation, this is the half equation. Chlorine gain 2 electrons to form 2 chloride ions. At the same time, where does this electron come from? It comes from the iodide ion. Iodide ion gives the 2 electrons to chlorine, and by itself, it undergoes oxidation in this process. Moving on, give the color and state of iodine and room temperature and pressure. So iodine is actually a gray-black solid at room temperature and pressure. Now, moving on, carbonyl chloride is manufactured by reacting carbon monoxide with chlorine. The process takes place in a closed system and an equilibrium is achieved. The conditions for this process are 200 degrees Celsius and 200 kPa. Explain what is meant by the term closed system. Now, a closed system is required for an equilibrium to be established. And by a closed system, it means like a closed container where no reactant or product can leave or enter the system. Next, state what the symbol delta H represents. It represents the enthalpy change of the reaction, and state how the value of this enthalpy change shows the forward reaction is exothermic by simply looking at the negative symbol. Because if the delta H is a negative symbol, it simply is exothermic. D. Deduce the value of delta H for the reverse reaction. Include a sign in your answer. Given that the forward reaction involves enthalpy change of negative 105 kilojoule per mole, going backward, it will have the same value but with a different symbol, positive 105. Right, moving on. Complete table 4.4 to 4.1 to show the effect, if any, on the concentration of carbonyl chloride at equilibrium when the following changes to the conditions are applied. Use only the words increases, decreases, or no change. Now, when the temperature is increased, it will actually favor the endothermic direction. So in that case, it will be going shift to the, if the equilibrium position will shift to the left, that will mean that the yield of the product will decrease. Next, some CO is added. So since we're adding a reactant here, that will cause a shift in the equilibrium position to the right, making more products. So our carbonyl chloride shall increase as a result. Next, when pressure is increased, this will actually favor the side with less gas. The side with less gas actually is on the right. There's only one gas on the right-hand side, whereas there are 2 gases on the left-hand side. So this also causes an increase in the concentration of the carbonyl chloride at equilibrium. So as the equilibrium position shifts to the right. Last, a catalyst is added. Catalyst doesn't affect equilibrium position. So hence it will not make more products. So there will be no change of COCl2 as a result. Now, question F. The equation for the reaction can be represented as shown in the figure. Table 4.2 shows some bond energies. Use the bond energies in the table and the value of delta H for the reaction to calculate the bond energy in kilojoule per mole of the C double bond O bond. Use the following steps. Calculate the energy needed to break the bonds in the reactants. Now, the energy needed to break the bonds in the reactants will be, well, there are two bonds to be broken here. Number one is this carbon O triple bond. So it costs 1075 to break this bond. And then there's another Cl-Cl bond that we need to break here, which costs 240 kilojoules. So altogether, that will be 1315 kilojoules. Next, calculate the energy release when the bonds in the carbonyl chloride form. Now, the carbonyl chloride has 3 bonds here, which is C double bond O and 2 CCl bonds. Now, we are not given the C double bond O bond from the table. That means we have to figure out another way to find out the energy released when the bonds are formed. Now, we are actually given the enthalpy change. And enthalpy change follows the formula of bond breaking minus bond formation. So we can simply find the energy of the bond formation by simply readjusting the equation to give us bond breaking minus our delta H. So by using this equation, we can actually follow the values here. Bond breaking we have calculated is 1315. And then from the question itself, it is negative 105. So altogether, it is 1410 kilojoules. And using this value, we know that the bond formation actually involves the sum of 3 bonds. That is the bond energy of the CO, as well as the 2 CCl bonds here. That costs 340 each. So let's add them all together. So 2 of them. Now, so 1410 is basically this bond energy of CO. Let's just call it, let it be X. Allow me to just annotate this. Let it be X. And we just calculate X. So this will be 680. So X is equivalent to 1410 minus 680. That gives you 740 kilojoules per mole. Right, next question. Complete a dot and cross diagram in figure 4.2 of a molecule of carbonyl chloride. Show outer shell electrons only. Now, here's a simple trick to know about how to draw covalent bonding. Now, covalent bonding is similar to ionic bonding because ultimately the atoms want to achieve a full outer shell. Now, given that the elements are as follows, which is carbon, oxygen, and chlorine, first we have to figure out how many outer shell electrons do we have. So each of them, right, of the atoms, by the way, for carbon is in group 4, so 4 outer shell electrons. Oxygen is group 6, so 6 outer shell electrons. Chlorine is in group 7, so 7 outer shell electrons. So to achieve a full outer shell, covalent bond is like friendship, where both elements contribute equal number of atoms. So carbon, in order to get a full outer shell, needs 4 more. In other words, it will request from the other atoms 4 more electrons. Now, whereas for oxygen, it will contribute 2 more for sharing, whereas in exchange, it will get 2 more electrons. That's how it gets a full outer shell. And chlorine will need 1 more. Now, the non-bonding electrons for carbon will be 0. For oxygen, there will be 4 remaining. For chlorine, there will be 6 remaining. So using this system, we know that oxygen, right, will contribute 2 electrons for sharing, right? It will contribute 2 electrons for sharing. Chlorine will contribute 1 electron for sharing. And carbon, in exchange, will also contribute the same amount. So in total, still 4 electrons. So 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. Then chlorine has a remainder of 6 electrons after bonding. So these are the non-bonding electrons. And then oxygen will have 4 more non-bonding electrons. Now, there's another trick for this question, which is use Lewis diagrams. I call it the line method. Carbon likes to form 4 lines. Given, well, as you have learned in organic chemistry, carbon prefers to form 4 lines. Oxygen, 2 lines, because it's group 6. Chlorine is group 7, so 1 line. Now, using this, we can actually translate this back to the diagram. And all you need to do is realize and count how many non-bonding electrons are remaining. And you just translate that back to the diagram. So there are two methods here. Right? Moving on. Number 5. Magnesium is the element with atomic number 25 in the periodic table. Calcium is the element with atomic number 20 in the periodic table. Complete table 5.1 to show the number of protons, neutrons, and electrons in the manganese atom and the calcium ion. Now, proton is the same as atomic number. So we just copy what's given. 25 for manganese, 20 for calcium. To find neutrons, all we have to do is simply taking the mass number, or should I say the nuclear number, right? Take the nuclear number and minus the proton number. So this will be 55 minus 25, that gives you 30. And this will be 42 minus 20, which gives you a 22. Now, for electrons, since this is uncharged, there are seen a number of protons and electrons. And that will be 25. And this one has a 2 plus charge. For an atom to form a 2 plus charge, it must donate 2 electrons to gain a 2 plus charge. So it has 2 less electrons, which means it has 18 electrons. Moving on, manganese forms several oxides. The formula of some of these oxides are shown. Suggests why manganese is expected to form colored oxides. Because manganese is a transition element, and the ability to form colored oxides is a unique feature for transition elements. 2. State which property of manganese is shown by the formation of several oxides. Normally, for group 1, 2, and 3, they kind of have a fixed oxidation state. For group 1 and group 2, it's usually +1 and +2 respectively. Unlike transition metals, where they can exhibit different oxidation states, and hence they form different oxides. You can actually verify this by looking at the examples, where this is actually +2, manganese 2 oxide. This is actually +3, manganese 3 oxide. This is actually an average of +8 out of 3. This one actually is a mix of +2 and +3 ions. And then this will be a +4, and this will be a +7. How do I find these answers? Is by thinking of oxygen, each oxygen carrying a -2 oxidation state. Or I can simply refer to a known compound. Like for example, calcium oxide, which is fixed +2 and -2, or aluminium oxide, +3 and -2. This is the quick way to do it, but if you're not familiar, you can do it step by step. Now, 3. State the formula for manganese 2 oxide, and actually we have found it just now, is MnO. Because the rule is swap and simplify, MnO2, Mn2 plus and O2 minus, swap and simplify becomes 2:2 ratio, and then we simplify this ratio, it becomes 1:1. So one manganese 2 ion reacts with one oxide ion. Next, manganese. This manganese oxide, right, is found in an ore of manganese. Manganese metal can be extracted from this particular manganese oxide using aluminium as the reducing agent. Define the term reducing agent. Now, a reducing agent is a substance that undergoes oxidation by itself by reducing others. I can draw an idea, which is essentially redox reactions are electron transfer processes. Now, when a substance gains electrons, it's called reduction. And the reason why this substance undergo reduction is because someone donates electron to it. So this thing is what we call a reducing agent, or you can think of it as the substance that undergoes oxidation. So to define it, we just simply have to say it undergoes oxidation by donating electrons. Right? Or should I say a substance that undergoes oxidation? A substance that undergoes oxidation by donating electrons to others, causing reduction in another chemical. Literally. Okay, next, complete the symbol equation by inserting the formula of the missing product and balancing the equation. So if you notice, it's following this format. AB plus C becomes well an A, and you should expect this to be a CB format. This is actually a signature displacement reaction. Now, so we should get aluminium oxide, which is a fixed ratio Al2O3. How do we find that? Aluminium is group 3, so form plus 3. Oxygen is group 6, so form -2. That forms a 2:3 ratio. And to balance this equation, all we have to do is simply just be attentive to it. Now, it's found that O on the left-hand side has 4. O on the right-hand side is 3. Now, usually some equations will involve least common multiples. So this one is a popular example of it. Now, we think of the least common multiple of oxygen for number 4 and the 3. The 4 and the 3 has a least common multiple of 12. So to make 12, I need 3 sets of 4, and then I need 4 sets of 3. 4 sets of 3. And that will make 8 aluminium required for this reaction, and then a 9 manganese needed, form from this reaction. And that's basically it. Moving on, manganese 4 oxide reacts with dilute hydrochloric acid as shown in the equation. Calculate the volume of chlorine gas formed in cubic centimeter at room temperature and pressure when excess manganese 4 oxide reacts with 50 cubic centimeter of 0.2 mole per cubic decimeters. Now, using the following steps, calculate the number of moles of hydrochloric acid used. Now, for this one, we need to use the given value, which is to use the formula concentration is mole over volume. Then we simply have to readjust the subject. Mole is concentration times volume. Now, before we can do that, we must make sure that our units are the same, because you can't cancel this unit if they're not the same. So we convert 50 cubic centimeter to cubic decimeter first, which is just by dividing by 1,000. So that makes 0.05 cubic decimeter. And to find the answer, we simply just have to take mole, which is the concentration 0.2, multiply by 0.05. And that will actually make 0.01 mole. Next, determine the number of moles of chlorine formed. Now, so looking at the equation, we see that for every 4 moles of hydrochloric acid, it forms 1 mole of chlorine. So according to the mole ratio between the Cl and Cl2, they are both reacting in a 4:1 ratio. This is given from the equation. So from our question here, in order to use 0.01 mole of hydrochloric acid, it seems like it will form 4 times less. So take 0.01 divided by 4, which is equivalent to, well, 0.025. No, 0.0025. 0.0025. Okay, moving on. Next question, calculate the volume of chlorine gas formed. So using this value, and given that it's a gas has a special property, which is 1 mole of any gaseous substance will occupy 24 cubic decimeter at room temperature and pressure. So given that we have 0.0025 mole, it will simply occupy a fraction of 24. Hence, to multiply 24, we get basically 0.06 cubic decimeter. And similarly, we have to convert to cubic centimeters, which is just by multiply by 1,000. And that gives us 60 cubic centimeters. Now, moving on. Next, describe a test for chlorine gas. Now, chlorine gas is a bleach, by the way, is like one of the only few gases that has a bleaching effect in water. So what we do is we can take a damp litmus paper, and then it will simply be bleached. Now, explain in terms of collision theory, why decreasing the temperature decreases the rate of this reaction? So because temperature is actually I would say it's related to the average kinetic energy of particles. When temperature is lower, particles move slower, right? Particles move slower due to the average kinetic energy of the particles decreasing. Now, this causes two things. Number one, frequency of collision between the reactor particles to decrease. Simultaneously, it also decreases I would say it will lower the fraction of particles possessing sufficient energy, or should I call it activation energy, to react. This fraction will be much lower. The percentage will be much lower. And ultimately, both of this lead to the frequency of successful collisions to decrease tremendously. Right, between reactant particles. Okay, next. Number 6. The structural formula of two compounds A and B are shown. A and B are members of the same homologous series. Give two reasons why the structural formula of A and B show that they are members of the same homologous series. Now, in studying homologous series, we learn 5 main characteristics. However, we have to use the ones that are appropriate for this scenario. Now, the first obvious thing that we see is that both of them share the same functional group. So the same functional group makes them being placed in the same homologous series. That's number one. Same functional group. Now, other features like having a trend in physical property is not obvious. And then having a CH2 difference is, I doubt that is not so efficient. We are not sure whether the answer will be accepted by the exam board or not. But one thing for sure is that we can see that both of them can share the same general formula, which happens to be CnH2n for alkenes. Now, next, explain why A and B are both hydrocarbons. Now, hydrocarbons are defined as substances that only contain carbon and hydrogen. Right? If it has other elements, it won't be considered as a hydrocarbon. Next, write the symbol equation for the complete combustion of A. Now, so complete combustion refers to, the word combustion means react with oxygen, and then complete means it forms carbon dioxide as a clean fuel. Sorry, not to say a clean fuel, but it doesn't form carbon monoxide, it forms carbon dioxide. Now, since this is a hydrocarbon that follows the formula, after calculation, after counting, it's C3H6. So C3H6 reacts with O2 and it forms CO2. And what about the hydrogen element? It also gets oxidized to form water, or should I say steam. To balance this equation, it will be easier for us to balance it from the perspective of carbon and also the perspective of hydrogen, since they occur only once, which makes it the balancing easier. So 3 carbon atoms are basically released, and then 6 hydrogen atoms. So we put 3 sets of water. Counting on the right-hand side, there is a total of 3 plus 6 oxygen, which is 9 oxygen. So the left-hand side, to balance this, we have to put a fraction. 9 out of 2 oxygen is used in this combustion reaction. Now, or alternatively, you can just make it into simplest whole number ratio, which is 2C3H6 plus 9O2 forms 6CO2 and 6H2O. This can be found by multiplying the ratios, mole ratios, by Q. Next, deduce the empirical formula of A. Given that it's an alkene, which follows the formula CnH2n, it is simply a ratio of C1 is to H, C1 is to H is to 2. Sorry, let me rephrase that. 1:2. Now, name compound B. Compound B has 4 carbons, so it's a but. It starts with letter but. Then it's an alkene, so it ends with an ene. And next thing that most students overlook is the position of the double bond. The double bond is located, or should I say the carbon-carbon double bond is located on the second carbon. So it's called a but2e. Now, F. A structural isomer of B is a member of the homolog series. Draw the displayed formula of the structural isomer of B. Now, structural isomers refer to covalent molecules with the same molecular formula but different structural formula. In that scenario, it will have a similar molecular formula, which is C4H8 after calculating. Now, what will be the version of it? It will be a but1e. So instead of carbon-carbon double bond on the second carbon, it will be on the first carbon. So we just draw 4 carbon atoms and then draw the carbon-carbon double bond, followed by making sure that every carbon has 4 lines. This is group 4. Then we place hydrogen atoms to complete the diagram. That will be our but1e. Moving on, compound B reacts with aqueous bromine at room temperature to form product C. The equation is shown. See, why is this an addition reaction? Addition reactions are just defined as a reaction that only forms one product, as you can see from the equation. 2. Describe the color change in aqueous bromine during this reaction. Aqueous bromine is brown, right, or orange. When it's integrated in a structure. Now, organic molecules in general, including haloalkanes, in general are colorless. So this thing turns colorless. This thing is colorless, basically. 3. Name product C. So we see that there are 2 bromine on the second and the third carbon. Second and the third carbon. So we call it a 2,3, signifying the position of the bromine atom. Dibromo, telling people that there are 2 bromine atoms, and it's just a deviation of a butane. It has 4 carbon atoms and it's saturated. Next, under certain conditions, 1 mole of B reacts with oxygen to form 2 moles of carboxylic acid D. Now, carboxylic acid D has 2 carbon atoms. Draw the displayed formula for carboxylic acid D. It's mentioned here that it has 2 carbon atoms. So it's a 2-carbon carboxylic acid, which is what we're familiar. It's just ethanoic acid. To draw the ethanoic acid, first, of course, 2 carbon atoms are drawn, followed by the functional group C double bond O, single bond O, single bond H. Then finally, we just connect, we make sure that all carbon has 4 covalent lines, and then we place hydrogen. Now, complete the symbol equation for this reaction. So it says that it reacts with oxygen to form this 2-ethanoic acid, right, given from the statement itself. So I form CH3COOH. And to balance this equation, we already have 4 carbon on both sides. And then I believe hydrogen is balanced as well. There is 8 hydrogen on both sides. And then we count. There is a total of 4 oxygen on the right. So I put a 2 on the O3. And that's basically for this paper. All right. Now, if you're struggling in IGCSE Chemistry, you can click the link below. And then we actually have weekly tutoring classes to help you in IGCSE Chemistry. And also we have lesson modules to allow you to catch up with whichever progress you're currently in. So if you're interested, you can click the link below and then seek help from us. All right. That's all. And I'll see you in the next one. Bye.